Calibration. It is very widely used in industries. It is the setting or correcting of a measuring device or a base level, usually by adjusting it to match or conform to a dependably known value, or act of checking or adjusting by comparing with standard the accuracy of a measuring instrument. It is the procedure employed for making adjustments or checking a scale for the readings of a system conforming to the accepted or predefined standard. That is to say that the system has to prove its ability to measure reliably. Every measuring system must be provable. The procedure adopted to prove the ability of a measuring system to measure reliably is called calibration. In this process, known values of input are fed to the system and the corresponding output is measured. A graph relating the output with input is plotted, which is known as calibration curve. During the process of experimentation, known values of input magnitude are fed and the corresponding output is measured. A plot of output against the input is drawn and is called the calibration graph. Threshold. If the instrument input is increased very gradually from 0, there will be some minimum value of input below which no output change can be detected. This minimum value defines the threshold of the instrument. Hysteresis. An instrument is said to exhibit hysteresis when there is a difference in readings depending on whether the value of the measured quantity is approached from higher value or from a lower value as shown. Hysteresis arises because of mechanical friction, magnetic effects, elastic deformation, or thermal effects. Hysteresis is a phenomenon which depicts different output effects when loading and unloading. It may be with respect to a mechanical system, electrical system, or any system. Hysteresis is the non coincidence of loading and unloading curves. Consider an instrument which has no friction due to sliding or mating parts. When the input of this instrument is slowly varied from 0 to full scale and then back to 0, its output varies. Hysteresis is a system arises due to the fact that all the energy put into the stress parts when loading is not recoverable upon unloading. Typical hysteresis curve. Sensitivity. It is the ratio of the linear movement of the pointer on the instrument to the change in the measured variable causing this motion, or is the ratio of the magnitude of output quantity response to the magnitude of the input quantity. For example, 1 millivolt recorder might have a 10 centimeter scale. Its sensitivity would be 10 centimeter per millivolt, assuming that the measurement is linear all across the scale. The static sensitivity of an instrument can be defined as the slope of the calibration curve. The sensitivity of an instrument should be high and the instrument should not have a range greatly exceeding the value to be measured. However, some margin should be kept for accidental overloads. Sensitivity of an instrument is the ratio of magnitude of the response output signal to the magnitude of the quantity being measured input signal. Sensitivity K is equal to change of output signal divided by change of input signal. Sensitivity is represented by the slope of the calibration curve. Sensitivity of the instrument system is usually required to be as high as possible as it becomes easier to take the measurement. Resolution or discrimination. It is defined as the smallest increment of input signal that a measuring system is capable of displaying. Resolution defines the smallest measurable input change, while threshold defines the smallest measurable input. Threshold is measured when the input is varied from 0, while the resolution is measured when the input is varied from any arbitrary non-zero value. Repeatability. It is defined as the ability of a measuring system to reproduce output readings when the same input is applied to it consecutively under the same conditions and in the same direction. Reproducibility. It is defined as the degree of closeness with which the same value of a variable may be measured at different times. Linearity. A measuring system is said to be linear if the output is linearly proportional to the input. A linear system can be easily calibrated, while calibration of a nonlinear system is tedious, cumbersome, and time consuming. Most of the systems require a linear behavior as it is desirable, that is, output is linearly proportional to input. This is because the conversion from a scale reading to the corresponding measured value of input quantity is most convenient, as one has to merely multiply by a fixed constant rather than a nonlinear calibration curve or compute from nonlinear curves and equation. Also, it is to be noted that all nonlinear calibration curves are not inaccurate. Sometimes they may be more accurate than linear calibration curves. Hence, many definitions of linearity exist. The best fitting straight line or method of least squares may be used to plot input versus output data.